friends, welcome to Colin Teaches Math. So today we're going to talk about some BC only tips. I made another video on just general AP Calculus tips, so here's some BC only things you need to remember to ace this test. Okay, no particular order. So first thing, integration by parts. You have to know how to do integration by parts. UV minus integral of v du, and you're always going to set it up as u and dv. So one part of the integral is u, the remaining part is dv, and how do you choose what u is? Flip it. If there's a log, if there's inverse function, a polynomial, exponential, or trig. That's the order you're going to go down in your head to choose what u is. If there's a log, then u is the log. If there's no log, see if there's an inverse trig, and so forth. And then underneath, you can set up du and v and plug it in. Second tip and trick, partial fractions. It's going to be on there, either in the multiple choice or in a BC only for your response. How do you know when to use it? 'Cause sometimes it's a little confusing when to use it. If you can factor the denominator, then it's going to be partial fractions, okay? And that's when you assign the whole temporary numerators. I think I've made a whole video on how to do this. Okay, next thing, BC only, Euler's method. I love a good Euler's method question because they literally say use Euler's method. In my class, I like to use a chart to organize our thoughts. So we like to do this, x and y, then the differential equation, the step size, delta y, x plus delta x, y plus delta y. I could make a video on this if you would like me to. And this is where you just start with the initial condition and you go ahead and fill it in. All right, next thing. Improper integrals. You need to be familiar with integrating from negative infinity to a number to infinity. You also need to be familiar with, check out this question. We're discontinuous at 1, that's improper. Here's another one where I'm discontinuous at the other bound. And then here's one where I'm discontinuous somewhere in the interval. So all of these on the board are improper integrals. Remember, you're taking the problem. So this is the problem here, here, here. Oops. Sorry, I meant this one to be x minus 5. Here, and then the problem for this one is at 1, which is in the middle. You're taking the problem, then you're taking the limit as b approaches the problem and replacing the problem with the b. Okay, next. You need to know parametric. Okay, parametric is going to be on there. Oh, let's do arc length first. Arc length is the integral of the square root of 1 plus dy dx squared from a to b. They could just say, what's the arc length? Parametric and polar. You have x of t, y of t, so this is all parametric. What do you need to know from this? This is really important. If they give you the velocity vector and they want the acceleration vector, get into the habit of saying acceleration is the first derivative of velocity and then give the vector. You always want to do that. You always want to state that you know acceleration is a derivative of velocity or velocity is a derivative of position. All right, what do you need to know in parametric? You need to know speed is dx dt squared and dy dt squared. I'm just going to write it as x prime and y prime. Total distance traveled is the integral of speed from A to B. You need to know dy dx is dy dt over dx dt. They love asking you like the particle's position. So say I'm gonna make something up. Say they give you x of 0 is 5 and y of 0 is 7, and then they give you dx dt and dy dt is given. If they want you to find x of 3, it's what I want equals what I'm given, plus the integral between the two of them, dx dt. Remember I said that's always the lower bound. And if they want y of 3, it's what I want equals what I'm given, plus the integral, but you're using dy dt. Okay? And last but not least is polar, and series, duh. Polar, just remember, x is r cos theta, y is r sine theta, area is 1/2 integral alpha to beta r squared d theta. And they can ask us a lot of questions about this. Think of polar as, it's a different parameter than t. So the parameter is going to be theta. So dy dx is the same formula as parametric, but now you're deriving with respect to theta. Polar questions are a little hard. I feel like we're due for a polar free response. I really hope not, but we'll see. And then last but not least, obviously, series. I made a whole review on, excuse me, the first part of series. I need to do another one on like Taylor, Maclaurin, Lagrange error. You need to know all of that. Series is such a huge portion of this course. So you need to know all of that. Look at my Unit 10 review. I made some review sheets, but I don't know. Series, there's a lot to write down, but know all of it. Okay? And that is the BC only stuff you need to know.